Hi everybody, we are starting a new chapter on multiplying fractions and dividing fractions. We're going to start out with probably the easiest step, and I find multiplying and dividing fractions maybe a bit easier than adding and subtracting. We're going to start out with multiplying fractions, and we're just going to work with whole numbers. So I drew a model here of, we're going to say we want 6 of the 2/3, or we're going to take 2/3 6 times. So I drew a model of 2/3. So that would be like me putting out candy bars and somebody, I'm going to blame it on Leonard, goes and eats 1/3 of each of the candy bars that are laying out rather than eating one whole. So we're going to have to add all these groups of 2/3 up. I just want to show you what's going to happen. So I know that every 3 of these is going to be a whole. So there's 2 wholes with a WH. So there's 1, 2, 3, 4 wholes, or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You have 12 thirds represented here, and I put the ring around them to show that that is equal to, you already know that 12 thirds is going to be equal to a total of 4. Now I want to show you with the arithmetic, with the actual numbers, how easy this is. All you do is multiply the numerators, which this is 12. I always put the whole number over 1, but you don't have to do that. You can just keep the denominator the same, because anything times 1 is itself. And you multiply both numbers straight across. There's no changing to common denominators. You just multiply straight across, and if you can reduce or change it back into a whole number or a mixed number, you can do that. So basically the way that you do this to multiply a fraction by a whole number, you multiply the numerator by the whole number, and you keep the denominator the same. Then you reduce and turn it into a mixed number if necessary. This is just a nice step to have the words for. So for the example is 2 times 3/7 is the same as 2 times 3 over 7. I just put the denominator on the bottom, and it'll be equal to 6/7. I did the algebra here. A times B over C, where this is the whole number, is the same as saying A times B over C. So what I want you to do is try these 3. So copy these down and then pause, and I will have my work and the answers up when you unpause. So what I did was showed my work here where I multiplied straight across, and if you look down here, I changed this improper fraction into this mixed number. I saw 2/4 could be reduced to the 1/2, so you should have gotten 4.5. Second one was more straightforward, and I do like to put these all over 1. That's just my preference. And I got 9/10. And the third one, you can see my work going straight across. I ended up with 42/5 and changed it into 8 2/5. So I want to talk about how to do this through a mental model. So let's say that you have 18 DS games and you're going to bring them to a sleepover, but your mom says, no, you can't bring all of them. You can bring 2/3 of them. And how many is that? So if I divide 18 DS games into thirds, so that I'm going to make a little grid here. It'll make sense why I'm doing it like this. So basically I set up a grid of 6 by 3, which is 18. So these lines right here represent the 3 parts. So in every single part, there's 1, 2, 3, 4, 5, 6 DS games. So my mom says, I can't bring all 18, but I can bring 2 of the 3 parts of the 18 DS games. I'm going to circle that, and I'm going to see that I can bring 12 of my DS games over. Okay, so if I have 18 over 1 times 2/3, that's going to be 30. Six thirds. Sorry, I was hearing something in the background, so that's why I paused. So 36/3 is also equal to 12. I can do it either way, but a lot of times when you have a number that easily divides itself by that denominator, you can do that. So what are the 3 of the 4 parts of 28? Well, I think about, can 28 be divided into 4? Yeah, it can, by 7s. So there are 4 groups of 7 in 28. Well, what if I only wanted 3 of those 4 groups? So that's 3 groups of 7. I would end up with 21. So that's how I reason through. You could even draw the 7s, 1, 2, 3, 4, 5, 6, 7, 4 times and circle 3 of the groups of 7 and count them and be 21. Okay, what if we have to estimate what's 3/5 of 26? Well, if you remember back at the beginning of the year, we talked about compatible numbers. We want to see how to get kind of close to that. And 5 and 26 are not compatible, but 5 and 25 are. So I'm going to change this to a more compatible number. And I know that there are 5 groups of 5 and 25, but I only want 3 of those groups. Not all 5 of them. I only want 3 of the groups of 5. So if I do that, I'm going to have about 15. And I'm going to put these little swirly equal signs. That's approximately equal to 15. So when you are estimating and you don't want that exact answer because you're going to get a really wonky denominator, go ahead and use the compatible number if it says to estimate. So if this would have been 29, I would have put it to a 28 to get pretty close if we were dividing it up by 4ths. Okay, so the mental math model is really handy for you to be able to picture what is actually happening. So don't discount this. Try it a couple of times, but I would, if you doubt yourself a little bit, go ahead and try the arithmetic way. It's really nice and easy when all you got to do is simply scooch it straight across to get that final answer. That's all there is to today's assignment. It's going to continue to grow in complexity as our unit continues, but remember to take great notes, and I'm sure everyone in here will do an awesome job.